Okay. Before I get into the actual presentation, this is just a cautionary words from our lawyers that there could be a few forward-looking statements in my presentation. Before you make any investment decisions or any commercial decisions per se, please do your own due diligence and feel free to contact UOP, Honeywell UOP for any further guidance. Okay. My broad agenda for today's discussion, I would like to start with Honeywell UOP's portfolio of offering on the SAF space, particularly on the renewable fuels, and we'll go for a deeper dive into Fischer-Tropsch pathway for SAF production, and a very high-level overview on what different parameters one would look at before choosing a particular pathway for SAF production. And I will also talk about the grand collaboration of two industry leaders, which is going to ultimately benefit the end users, the customers here. So before we start into the SAF technology part, let's have a quick walkthrough on why this particular subject is of so importance now. As both our chairs, the chair and the co-chair, talked about it, this is kind of, we would say, more of a significant topic for today. Just because if you look at this from a global perspective, what are the things which is driving the SAF market in itself, right? On the shorter term, say for example, till 2030, we believe the government incentives and mandates pretty much, I would say, a Western phenomena based on US, Europe, and UK. So these government incentives and mandates is going to drive the market. And on top of it, corporate commitments towards GHG reduction. So this is the other big parameter which is influencing this market on SAF. However, this is for short term. If you were to look at it on a longer term perspective, and that is where I wanted you to wanted you to focus on the chart that is on the right side, right? So this is kind of what UOP per se projects as a global SAF demand. What we see today in 2025 as a very small market is expected to grow as high as 35,000 kilo barrels a day. Okay, so this is a kind of a market that we are talking about. In terms of metric tons, so this is about 150,000 kilo metric tons. So there is a huge market which is developing, but we wanted to encash this particular market, right? And the other near-term challenge that we are seeing is, today whenever we talk about SAF, it is pretty much limited to FOGs, right, through the HEFA pathway. And at max, it goes to the next level of ethanol to convert it into jet. But are these the sustainable feedstocks that is going us to take all the way, say, 2030 and beyond? Probably not. We'll be either limited on the feed source, or the regulations would limit us from using these feedstocks for further use for SAF production or the jet fuel production. Okay? Just changing gears. If you were to look at this from an Indian scenario, whatever we are showing here is coming from Deloitte's report. So what we see here is, in India, today's market, from an ATF production perspective, 50% of ATF is being exported, which constitutes about 3% of the global demand for SAF. Okay? Sorry, it is not SAF, it is ATF today. So this is about 3% of the global demand. And if we were to project this with whatever our chair just now pointed out, and also Honorable Minister yesterday pointed, like if we were to go with a 5% indicative blending by 2030, this translates to easily 80 kMTA of SAF requirement in Indian market. But if we were to just focus on this particular market, we are playing in a much smaller domain, I would say. So the way that we are looking at Indian producers in this case is why India is not a producer for a world on the SAF front. There are two big drivers why India can invest more on the SAF production. Number one, we can be very easily cost competitive if we were to compare against our APAC competitors, okay? This is very well proven on the green hydrogen front. So there is no brainer that even in the SAF space, India is going to lead in terms of cash cost of production. So this is one of the biggest levers that we have. And if you were to extend this further, the proximity to the major hub of European Union is going to help us a lot in the global play on SAF. So with this demand, what we wanted you to look at is a complete portfolio of solution that Honeywell UOP can offer in this space. Okay? So to begin with, The first and the foremost, which is readily being off-taken in the industry right now, is the HEFA pathway, which uses FOGs, basically fatty acids, oils, and greases. So any of these feeds can be processed through UOP's eco-fining process or the UOP renewable jet fuel process to make SAF. And if you want to use existing refinery assets, we can always go for co-processing, either through a hydrocracking pathway, which is UOP's union fining or unicracking pathway, or we can take it through the FCC pathway. Both of these routes will help us produce partially renewable fuel. It could be the kerosene or it could be the diesel. Okay? Leaving all this, if we were to go into the next gen market, so that is where biomass, MSW, and ultimately the CO2. So these being feedstock, these being used as feedstock is going to drive the market beyond 2030 and 2040s. So for addressing these particular feedstock, UOP have our own technology on RTP, which is a pyrolysis process, which could be the pyrolysis oil produced will be upgraded using hydrotreating to produce SAF, or else the two niche pathways. Either we can go with methanol pathway. In this particular pathway, any of those feed material, be it biomass, MSW, or the carbon dioxide, is going to be converted into an intermediary methanol, and this methanol will ultimately be converted into SAF. And the competing pathway for this is the Fischer-Tropsch pathway. So the same feed material could be converted into an FT crude and then upgraded into SAF-rich material. So for both these processes or both these pathways, UOP does offer our e-fining process for methanol to jet conversion and Fischer-Tropsch with FT unicracking process for the Fischer-Tropsch pathway. And on the ethanol space, UOP does have our ethanol to jet process, which would convert the ethanol into SAF-rich material. So this is a complete gamut of process technologies which UOP offer in the SAF space. Now, I will take you a bit more deeper into the Fischer-Tropsch pathway, right? So this is how an overall complex of a Fischer-Tropsch pathway would look like. So be it any feed, be it waste biomass, municipal solid waste, or gas, biogas, landfill gas, CO2, the first and the foremost step is we need to convert this into a synthesis gas, right? So generating syngas is the first step. And depending upon the feed that we are processing, the quantity of contaminants that will be in this syngas varies. And hence, this needs further treatment to remove all those contaminants. Once the syngas is conditioned, now we will pass this through a Fischer-Tropsch building block, which is going to convert this syngas material into a Fischer-Tropsch crude. And ultimately, this Fischer-Tropsch crude has to be cracked back to put all the molecules in the right space, which is less than C18 range molecules, to meet the ultimate SAF product requirement. Right? And the another major advantage of this particular process is this gives a flexibility either for us to operate the unit in SAF mode, or if there is a need, we could do diesel production, and if there is a need, we can also do base oil production. So this is a very high level overview on the SAF pathway. And from there, if we were to move into UOP's particular offering, so UOP has FT unicracking technology, which takes in feed from the Fischer-Tropsch process, which is nothing but the FT liquids and waxes. So this material would need to be cracked, as I said, to less than C18 range material. The unfortunate problem, and which presents a bigger opportunity, is this. The FT material is highly paraffinic, and once we crack it, yes, very good material to meet the ATF range, but the problem is this will not meet the freeze point requirement. And hence we need to go for the isomerization step. So together with hydrocracking and isomerization, we would ultimately meet the SAF product specification as per ASTM D7566, right? Like any other cracking process, this cracking process would also generate, I would say, byproducts, the off gases and naphtha. If there is an offtake, well and good, so this can be sold in the market, but primarily we would aim to reduce this particular byproduct material. And in the eventual scenario where we will be left with some amount of this byproduct material, that is where we talk about the carbon efficiency, okay? So the moment this naphtha and off gases are let out of the process, that much amount of carbon is lost, not in the form of SAF. So the carbon efficiency of the process is going to be less. So during this scenario, we would try to integrate all this byproduct carbon material back through a recycle reforming and generate more syngas. And ultimately, if you look at a SAF complex, with all different feed material that we start with, we will ultimately make just one product, which is SAF, going out of the unit. So this means eventually my overall process carbon efficiency is going to be very high in the order of 90 to 95%. Okay? So that is one of the biggest asserts and advantage of this particular pathway. Okay? So having talked about the technology in itself, yes, everybody in this hall will know that these are technologies which is there in the chemical engineering domain for many, many years. However, the systems and the market and the industry has progressed far ahead. These are not just the paper technologies. People have started investing in it. So this is just a glimpse of what UOP has done in this particular domain. We have 3 distinct customers and 3 distinct licenses sold in the recent past, in the last 2 years. So we have one unit, DG Fuels in USA, who are converting biomass material through gasification route and taking the FT pathway to produce SAF, and it is a 13,000 barrels a day unit. And a much smaller unit in Uruguay. So in here, it is a reforming pathway combined with FT to take it into SAF. Basically, the feed here is a biogas coming from dairy farm. Okay? And the third distinct license that UOP has sold is for USA Bioenergy. So this is once again a gasification pathway and FT to take it into SAF. And this is a 4,700 barrels a day unit. So these are just some examples which we wanted to quote you that this market is actually progressing. But before we get into selection of particular pathway, we wanted you to be aware it is not just a single pathway. There are multiple competing pathways available in the industry, right? So one comparable technology or comparable pathway to Fischer-Tropsch is methanol. So each one of these pathways has its own unique advantages, and we need to do this detailed analysis before we settle on a particular pathway for our ultimate project. So just to quote one example, if you were to look at ESAF, probably the methanol pathway is better. But if you want to do a biosaf, then Fischer-Tropsch pathway would be better. Okay? And if you want to adopt a hub and spoke model, because these are pathways which is dependent on the feed source, which is not available readily in single source. So we need to collect it from multiple sources. So depending upon our feed source availability and the location, we can go for a hub and spoke model. And in such hub and spoke model, what is our giveaway? Maybe a methanol pathway is better, but the giveaway is how much my capex and opex and ultimately cash cost of production is going to be. So this is a parameter which need to be evaluated before we settle on a particular pathway. And also the product flexibility. Should I just focus on SAF, or should we have the flexibility of going for a base oil as well? So if we have product flexibility requirement, then a particular pathway is suited better. Okay? And with all this background, I just wanted you to introduce, and this is my last slide, sir. We have an industry collaboration between Honeywell UOP and Johnson Matthey. This is a non-exclusive collaboration where we are working together to ease the burden of the ultimate end user here, people like you, the customers, the refiners. So the people who involved in project development knows this very well. It is not a simple task to coordinate with multiple licenses to get the project going. So from that perspective, UOP and Johnson Matthey has joined hands together, and we are offering end-to-end solution right from a syngas production all the way either through methanol pathway or the Fischer-Tropsch pathway for the production of SAF. So we have Johnson Matthey's FT cans technology, which is the Fischer-Tropsch technology, and UOP's FT unicracking for upgrading the Fischer-Tropsch crude into the SAF range material. And if we were to start with CO2 as our feed material, Johnson Matthey's Hycogen technology along with FT cans technology would help us together with UOP's FT unicracking. And if we were to talk about the methanol pathway, yes, once again, Johnson Matthey's Emerald technology with UOP's e-fining process will help us meet the end product requirement. So the key depends on what feed you have and what is the market product target requirement that you wanted to target. Based on that, we can help you with evaluating the multiple pathways and settling on the best pathway that is suited for each and individual customer. By this, we don't want to be technology, we certainly want to be technology agnostic. We can evaluate everything for you and come up with the best solution that suits your requirement. And thank you very much for your time and listening.